Welcome, ladies, jelly spoons, and attack helicopters. Alex here. This is the next part of the 32-bit 3D printing series where I actually do a board review. Now, before we get into this, realize that if you've never seen one of my videos before, you might want to go back and check out some shorter ones to see if you know what you're getting into. This is not going to be like I show you how to plug this into like your Creality printer and then like run off a vase or something like that. I want to get more in depth into the hardware, the software support, some of the options there, some of the shortcomings, some of the benefits, and that type of thing. So it's really nuts and bolts, nitty-gritty stuff. If you're not interested in that, then just go ahead and skip or watch it. You might have fun. Who knows? You can always stop it later on if you start to get cold feet. Anyways, I thought this would make a great board review video because this is one that plugs into the most popular system, which is the Ramps Mega Combo, and it just replaces the Mega part. And we'll get into all of that as we go. And I'm sorry this took so long to get out, but as we get into it, you'll see why it took so long and why it spilled into part 2, maybe part 3? Probably just part 2, I hope, because I want to get to other things with my life. So anyway, with no further ado, I present to you the review. Alright, so first, full disclosure, no money's changed hands for this review, and it's not sponsored or biased in any way. Alrighty? This board came to me via the middleman of Mod Mike, who wrote the Marlin installation guide for the rearm, and then it was sent directly from Roy at Panikit Devices. So with that taken care of, I'm going to break this down into 4 basic parts. What it is, what it isn't, what it has, what it's missing. Then I'm going to give a little summary, tell you who should and should probably not buy it. And then there's going to be a part 2 to this video that goes deeper into the nerdy details, because I don't want to blow people away with too many tangents. So quick history on the board. It came to life via Kickstarter back in January of 2017, so I guess that's like 2 years now. It was designed and sold by Roy Cortez at Panikit Devices, who are a small company that do some interesting things. They have some nice quality boards out there, and they're one of the few companies out there that's doing kind of new and different things with the step stick format. And the board is completely open source, so you can look up all the data on the website, and that's great for, you know, tinkerers and experimenters who have to solve particular problems and really need that data. Basically, it's a 32-bit ARM controller slash, breakout board, proto board that fits into the Arduino Mega footprint, but is specifically made to be a plug-in replacement for the Arduino Mega in a Ramps setup, so it overcomes some of the problems that we've seen there. More on that later. It inherits from the Smoothie project, which in turn inherits from the Mbed project, which also uses the LPC 1768 32-bit processor from NXP. And if you're familiar with the Mbed project, a lot of those libraries will work right on these boards as well. Now, support and general usage for these NXP processors in the general world is not quite as wide or as deep as, say, like the SAMD processors that are used for Arduino or the STM32F processors that are used for a bazillion things professionally. But since they are used in Smoothie, they are one of the big 3, I would say, in the 32-bit quote revolution, at least as far as like adoption and development, along with the STM32F by STMicro and the SAMD by Atmel. Now, bootstrapping off of an established system like, Smoothie and Mbed allows you to pick up where they were working and then kind of take it in your own direction. So you don't have to do things like get into the nuts and bolts and write yourself a new bootloader and figure out how to load the firmware in and all that kind of thing, because that's already done for you. And these particular processors take their firmware upgrades just right from the SD card that's on board. Just drag the binary onto the SD card or upload it directly from your IDE, and it'll flash it and reload it as soon as you reboot the machine. So in the broad sense of a comparison between the LPC 1768 as compared to what's on our Mega, we're running at 100 megahertz, which is many times faster than the 16 megahertz chip that we have on the Arduino Mega. There's also twice as much program space and RAM. And then switching from the Arduino Mega to the Arduino Duo, one nice thing about the rearm is that its GPIO pins are 5-volt tolerant, the digital pins, whereas on like the Duo, they are absolutely not, which can solve a few potential problems we might have. And then Panikit has also added onboard level shifting from 3.3 to 5 volt, so you can properly drive the gates of the MOSFETs that are on your Ramps board, since they're meant to take a 5 volt logic signal and won't fully turn on without it. And I talked a lot about that in the Duo conversion video, so you can dig through my archives if you want to check that out. Also, if you recall with the Mega, if you're back powering from your Ramps to your Arduino, the regulator tends to get hot and can even pop if you're drawing a lot of current from it. This is particularly troublesome because it barely has enough current capability to drive one of the full graphics smart controllers with an SD card. And if your smart controller happens to have a magnetic buzzer as opposed to piezo buzzer, then you're kind of sunk. And I know that from experience. The rearm has solved this by putting a much better power regulator on board. And it's good enough that even if you back power from your ramps, your graphical display won't have any problems. And I've even back powered it with the graphical display at 24 volts and had absolutely no problems. So woohoo! So basically intention was an Uber ramp setup plus SmoothieWare. But Smoothie's not the only option, because in the meantime, Marlin has swummed. What's the present perfect conjugation? We'll go with swum, even though it sounds weird. Marlin has swum along and added support for the board, so you do have choices now. There are also reports that people have gotten Clipper running on the rearm, so that is possible as well, apparently. I have not tried it myself. Personally, I ran Marlin on it because I already had a Mega setup that had Marlin 1, so it allowed me to make an apples-to-apples comparison over the course of the time that I tested this. And the rearm has kind of been adopted as like the de facto baseline development board for the Marlin project as far as their 2.0 branch is concerned. But be aware if you're running it that they don't have a stable release yet. All development is being done in the bugfix branch, which is the actual branch that you would download, and that's kind of a rolling release. So every release is going to be slightly different. It happens very often, so be aware of that. For example, there was a bug with one of the new features where things were shifting ever so slightly, as you can see here on this kinematics platform that I was working on that didn't print square. And then if you don't care about like bleeding edge features and like really get in and tweaking the nuts and bolts of things and you just want to try it out, SmoothieWare is a perfectly viable alternative. It's much simpler to use, much simpler to set up. It just doesn't expose as many options to the user, so you don't have as many choices. It should also work out of the box with many common peripherals, or at least peripherals that are common to the ramp setups, with a bit of a caveat. Like these full graphics controllers need to have a little bit of a slice and dice modification to the cable. They also don't play very well in certain modes with trinamic SPI drivers, but I'll talk about that a little bit later and then more in the second part of this video. Alright, so first of 4 sections down, what it is. It's a drop-in replacement for the Mega that gives you 32-bit printing. Boom. It's specifically made for ramps, so many of your peripherals works. It'll run 24 volts without a lot of mods. You can back power it without worry because there's a better onboard regulator, and it solves the 3.3 volt logics problem that we had moving from the Mega generation to the Duo generation, where they didn't have either 5 volt tolerant pins, and the output of the logic was 3.3 volts and wouldn't fully turn on our MOSFETs and other peripherals. Although bear in mind, the analog input pins are not 5 volt tolerant. They are made to run at 3.3 volts, so please don't plug 5 volts in there or you'll have a bad day. Again, I'll talk more about that later. Alright, section number B, what it isn't. Now this is not a one-stop, all-in-one board like your Duet, your Smoothie board, your Rambo, etc, etc, etc. This is meant to replace a part of a particular system, i.e. the ramp sandwich system. And at $45, it's really not that big an investment to take a currently existing setup and then boom, you have 32-bit printing. But even if you do have to buy a ramps and the drivers for it, it still prices it very competitively against a lot of the premium boards. But as you know, if you've bought any of these overseas kits or if you watched my ramps comparison video, a lot of these ramps boards are not exactly premium. And since Big Tree Tech released their source files for the ramps 1.6, it's probably your safest bet now, provided that you get one with decent build quality. I did a review of that if you want to check it out. It was pretty limited because my headers were bent, but I have gotten one in the meantime that was fine and I've been using that. I also plan to do a review of the upgraded version, the 1.6 Plus, in the near future as soon as my stupid drivers come in, so stay tuned for that. Now what it also isn't is it's not a one-for-one swap with the Mega. You are missing some pins here, although not quite as many as in this note here, because I did find out that a few of these pins most definitely surely seem to be available, so take that with a grain of salt. But regardless, it uses a 100-pin package IC just like the 2560 Mega does, except they had to cram a lot more technology into these, so choices had to be made. You end up with with fewer PWMs and fewer analog inputs. Also, if you've ever worked with one of these microcontrollers from scratch, you know that there are tiers, usually like 3 choices or so for each pin that you can make. So it comes down to choices not only of the 100-pin package, but it also comes down to choices of what you're going to assign each pin to. And also bear in mind, a lot of these you can change in the firmware as well. And fortunately for us, since this is open source, you can hop over to panicit.com's rearm page, go down to the design files, and see exactly what choices they made. So since we're making comparisons to the Mega here, let's talk about what it has, as in, non-Mega features, extra Mega features. Obviously, we have 32-bit compute, we have a higher clock speed, we have more RAM, we have more program memory, we have higher precision on a lot of the inputs and whatnot, and we have additional I/O. Whether or not it's used by the firmware is another story, but there is CAN bus on board. There's a quadrature encoder input, there's a native USB 2 serial, and instead of talking about what pins we lose, let's talk about what pins we gain. You see these extra headers hanging out of the side here. I'm just going to call them the J headers, like J4, J5, J6, etc., etc. Those were meant to be like additional courtesy headers. Some of these pins are unique, some of them are redundant with other pins on the board, but it's meant to make it a less jumbled adapter-y kind of a mess. And to use slightly less obtrusive cabling like they use for their own VIC-2 2 controller. That's going to bring me to another tangent, which is confusing pin naming conventions. Now, they tend to use the names of the pins as they're designated on the IC package, as in P0.1, P0.2, that type of thing. And the pin map on the Panicit site shows us the equivalent mega pins, which will let us know approximately where they go on the ramps board, since they use the same numbering convention. But when we get to the J headers, we kind of lose our way a little bit, and we end up having to flip back and forth just to find where they're routed. Which is not the end of the world, but there's also no silkscreen numbers on the board itself, on the top or the bottom. I would much rather see something like in my favorite cheapy clone mega board, the Elegoo ramps clone, where they have the pin designations silkscreen on the top and the bottom, and then they also have them on the sides because it's a stackable sandwich board and the top and the bottom might be covered up. That kind of lack of consistency carries over into like at least the Marlin pin mapping, where they use the IC designations for the most part, and then in parentheses they have the digital pins, except where it wasn't listed on Panicit, and then it just kind of says ETH, which goes to the J12 header, the Ethernet GPIO port, which again just adds another step when you're trying to move these pins around. And then there's the additional like Marlin proclivity for like masking pin numbers behind redefines and macros that may or may not be in the header file that you're looking. So for example, I was trying to see if I could work with the hardware SPI pins and it wasn't in the header, so I had to go to the HAL folder and then the LPC 1768 and then scroll down, do a full text search for like SPI, and eventually I was like, okay, boom, there they are. But I did find more actual pin designations on the actual design files from Panicit. Since it's open source, I could just open these up and then trace to where they came from. Now, Roy uses DipTrace, and you can get a free version of that runs on Mac OS, Linux, and Windows. There's a wine wrapper around the Mac and Linux version, so you don't have to worry about it. I think I had to register to get the free version, but it runs pretty well. Although it'd be nice to see something like KiCad or an open source program used. But I could go from that and cross-reference it a little bit with NXP's data sheets, which are not as good as like ST's sheets, but I was eventually able to track down all the functions, cross-reference them with what's there and what's not, and make my own spreadsheet pin map, which is still not complete, but it's complete enough for what I need to do in part 2 of this series, where I get into some of this nerdy stuff. So you have a little taste of what you're getting into if you decide to watch that video. Now, this is not accusatory right here. I'm just going to kind of direct this into the void. I don't think end users should have to deal with that type of confusion, especially if you want them to develop on your platform and you're trying to sell them something. And I understand that Panicit developed this for Smoothie Board, not for Marlin, but just as an example, I was messing around with the adapter board just for the ramps, and there isn't even a complete map for that around. So I had to make one of those myself with the PCB files and with an actual ramps board and a multimeter actually beeping out the contacts to see where they were routed in conjunction with the schematics and the board pin mapping. This is a project that I've been picking at for a while, and as you can see right here, it has the pin designations, the actual board numbers, and then the various functions that are available, as well as the ones that are selected and where they're assigned. Then there's also an ASCII version of that chart in the actual header in the firmware, as well as an ASCII ASCII list of the pin maps and the various designations that you can use there. Not only is it easier for developers, it's easier to read, it saves a lot of time, but it saves you a lot of time on people coming and asking you how to do this and that, where you can say, well, it's all just laid out, just assign the pin to the function that you want. And I know this is probably better or less for part 2, you know, the nerdy details video version of this, but to quote Adam Sandler, I have the microphone and you're going to listen to every word I have to say. If you're a compulsive tinkerer like I am and you have boards that look like this lying around, then it's very appreciated if you don't have to go through, pull up 4 different documents across 3 different monitors with a board in your lap and multimeter probes in your teeth just to figure out where your pins go. There's also no Marlin firmware links on the actual rearm product page, and most of the setup information there is for SmoothieWare, but the hardware information does carry over. And like I said before, ModMike did write a installing Marlin on rearm page on the Marlin firmware website, so that works pretty well and you can use that. And if there's enough interest in me making a video version of ModMike's guide, kind of like I did for the Duo Marlin 2 setup, I can put that up. That's not really a problem. Now, the rearm has also fixed another hardware niggle that we had between the ramps and the Mega Combo, and that's that if you wanted to choose between powering it off of USB separately from the ramps board or back powering it from the ramps board, you had to physically desolder the D1 diode. But Panikit has supplied this nice little jumper so you can choose between the two of them. No desoldering necessary. And again, that internal backfeed power can be up to 30 volts as long as your ramps board can take it, i.e. the poly fuses and the capacitors. I had no problem running 24 volts with the internal switching power regulator. Now the other header on this side, you'll see J4, is a breakout connection for the hardware UART, which is also a very nice touch. Now the J headers on the bottom are to solve yet another problem that we had with the ramps Mega Combo, in that you had a problem where you couldn't use certain peripherals together because of conflicts on the pins or adapters to fit over each other. So some of these pins, all the ones that are in blue, are available on multiple different connectors. So for example, J3 might be used for your control panel, as well as J5, and then there's also a little breakout for a servo right there on pin D6. And then J12 can either be used for an Ethernet daughter card, or you can use it for general purpose I/O for things like, I don't know, extra bells and whistles, or cable select for your Trinamic drivers, etc., etc. Now, one result of moving to the 3.3 volt logic chip is that your end stops are going to be 3.3 volts. That's fine for mechanical end stops. You shouldn't have any problem there, but optical end stops may or may not work with 3.3 volts, so make sure yours do before plugging them in. There's also a header on the other side that breaks out your analog inputs for your thermistors, in case you have a setup where you're having problems with the readings because of noise. Basically, they patched up the grounding scheme to just be a little bit better and gave you a separate analog ground point, as is standard practice. However, it is an either-or proposition, so you have to solder these jumpers if you want to use the rearms inputs instead of the ramps inputs, and there's a guide on how to do that on the rearm subsection in the Panikit website, so I won't reiterate that here. And since I'm talking about the analog pins, now's a good time for a special safety note. You'll notice in the Panikit documents right here that they say the pins are 5 volts tolerant except for the analog pins, which are 3.3 volt. And there are a couple other exceptions to that as well. Now, what's very important about that, as I've warned in some past videos talking about logic levels, is that things that either specifically work at 3.3 volt or passive components like mechanical end stops and thermistors, they're fine with the voltage levels, whether that's 3.3 or 5 or whatever else. But you have to make sure if you have an active component like certain thermocouples and like servo boards and things like that, that you are not getting a 5 volt signal sent back into a 3.3 volt port. Because on these chips, if you plug 5 volts into the analog pins, you will fry your analog converters. Just like if you were to plug 10 volts into the analog ports on your old Mega board. In my research, I saw a couple posts on various forums where people were blaming Panikit for their various pins blowing out, where it turns out that they were just sloppy about their wiring, didn't assign their pins properly, and they had just fried their ADC with a 5 volt signal. Make sure you do not do that. Things like display panels are usually okay, but make sure to double check, because even though they're powered off of 5 volts, they have a chip on there to knock it down to 3.3 for the SD card, and then they're not outputting any dangerous levels back to the board. And speaking of displays, the ones that are touted to be reported are your CR10 stock displays, the RepRap discount full graphics controllers with some caveats, the Vicky 2, the Mini Vicky, which are both from Panikit, and a few others, probably character-based displays. I have to try that out, and I'll get to those type of tests in part 2, the extra nerdy details. Now, the RepRap discount, I2C, and Vicky 1 controllers, they require special care and a different adapter. So those do work with a caveat, and it's likely that any of the panels that work off of the same driver boards will probably work as well. And while I do have a lot of junk parts around, I don't have every panel to test, so sorry about that. And while you can use the SD card on your panel if you choose, there's also an onboard SD card slot which you can use for both updating your firmware and for loading your models for untethered printing, provided that you make the proper selections in your firmware. So since I was talking about the 3.35 volt tolerant analog pins, let's talk about what else it may be missing or what may be different. Well, obviously 5 volt logic tolerance is one thing, but a lot of pins. Now, as you can see here as a note in the Marlin firmware, there are quite a few pins that are not present that you used to have access to on your Mega. It comes to around like 12 to 16 or so, and again, that's just the result of choices on the part of the 32-bit architecture folks. It's also present on the Dua and others as well. And again, you can go to panikit.com and look at the tech documents if you want to see exactly what they used, and you could just pull up the data sheets for these chips if you want to see what else would be available, or if you're not absolutely sure on particulars. And again, these features were just chosen to snatch some of those pins away so they could stay in the 100-pin package and still shoehorn more features into the new generation of chips. And the brunt of that was borne by PWM and analog I/O pins. So generally it means you might find yourself a little bit more cramped in terms of peripherals without pulling some dirty tricks. One example of that would be to make better use of your I2C bus. Now, if you've ever looked at your ramps board, you probably saw, or maybe you didn't, this little tiny header all the way in the corner that says I2C on it. That's just a 1 or 2 wire serial communication protocol that's not used as much because it isn't, as sexy as SPI. But one of kind of like the base bedrock uses of that in the Arduino world is taking your regular character LCDs, which use like 14 wires, putting those in series and running them through I2C. Which, even with the minimal bit mode that we tend to run these panels in, will still save you quite a few pins. With a practical and implemented example as far as 3D printing is concerned being the multiplexer that's used on Prusa's multi-material upgrade. And I did originally ramble for like 10 minutes about other options like daisy chain SPI, other shift registers, DMA GPIO expansion, but I'm going to put all of those into the second part of this series because they don't pertain particularly to the review. But getting back to the 3D printing issues that are at hand, another thing that you may or may not miss going from the Mega to something like a Rearm or any of the 32-bit platforms is an onboard eeprom. But if that is an issue for you, you can grab one of these, which again is just run off I2C interface, and it should be fully supported in most firmwares. At least it is in Marlin. Alright, so let's sum this whole thing up. The first obvious use is, well, people who have existing ramp setups. If you have a bunch of money existed in your ramps and your peripherals and you have everything working right, you know that your motors are well matched to your drivers and you have an LCD panel that you like, then it's easy for you to just take this, plug it in, make the changes in the firmware, make sure all your hardware is compatible, and then just go for it. Also, if you have multiple machines and you're on a budget and you have maybe several ramp setups, it's easier for you to have maybe a Mega sitting in the wings, and then you also have this rearm that you can swap from one printer to another depending on which one you're using. Because it may be very possible, like you have a Delta, you have a Cartesian machine, and you have like your Tinkerer machine, but you're not using all three at the time. time. You may not even have them all set up at the time. So why pay a bunch of money for a board that's going to go into a printer that's going to sit in the closet like 9 out of 10 months? And then finally, like fans of just modular systems, if you're the kind of person like an enthusiast that just likes to swap things in and out, try different drivers, try different boards, try this, try that, then obviously something where the individual components are more accessible is going to be more attractive to you. In that same vein, tinkerers, investors, inventors, and coders, they're going to be more attracted to something like this as well, where the point is not to have one big unified tweaked out machine, but whether you may have something that is constantly going to be swapped out to try different hardware, etc., etc. And that leads us to the next category: who should probably not buy this? Well, fans of integrated systems, obviously. If you're looking for that type of just one motherboard that does it all, there are options out there. So feel free to go ahead and take advantage of those. Heavy-duty machine users, they might want to look into something that's capable of putting more heavy-duty drivers on there. For example, like big CNC machines or gigantic 3D printers, because this is not a limitation of the rearm board itself, but rather a limitation of the step stick format that plugs into the ramps. There's only so much area before you reach thermal saturation that you can use for heat sinking those chips. And while it is very possible to run jumpers off the board and run some of the large like 4, 5, 6 amp CNC drivers, you may do well enough with something like, you know, a duet board that has the TMC 2660s on it, can take a bit more current right out of the box. Also, folks that require a full warranty and service for as much of the system as possible, they might want to give it a skip, because if you're breaking a board down into modular parts, each of those parts obviously comes from a different company. So if you're looking for one system where you have, you know, the service and the warranty and the parts all from a single source, then you might be better off going with a unified board. What comes to mind are, like, you know, educators in schools and things like that when you're setting up an entire lab of printers that are identical and you want to have one troubleshooting source. And then finally, KISS principal proponents. Keep it short and simple, or keep it simple stupid, whichever you prefer. There are people that just don't like looking for parts, and they want to know if this is going to work with that. They don't like fiddling with individual trim pots. They just want it all in one place and they want to plug it in and it works. So those are the types of people that probably wouldn't be comfortable with the ramps setup to begin with, and they might be happier with a unified board. Now, normally in a regular review, this would be where I do a print of a vase or something like that and show you how awesome it is. But honestly, I have had this board in my testbed printer for like a month or two now. So basically, everything that I've printed in all of the videos that I've posted in the meantime have been done on this board. So it seems a little bit superfluous at this point, but I'll just go ahead and say I didn't have any problems with it. I didn't have any problems with the setup, and I didn't have any problems with printing. Initially, a few months back when I did get it, I was having problems with tethered printing, and that was one of the things that held this review off, because I wanted to see if they were going to work that out in Marlin 2.0, and it has been fixed in the meantime. They revamped the entire system. That's not to say that I don't occasionally run into bugs and quirks, but that's more an issue with the firmware than it is with the hardware. I didn't have any problems with the hardware, and if you want to hear more about that wacky stuff, you can click on the uber nerdy part 2 of this, where I'm going to go more into discussion about those little details, things that I would like to see in the future on the part of both this hardware and the firmware support on various sides, and delve into issues with like some particular peripherals that I have around and whatnot. So if you're interested in that, we'll see you there. Otherwise, thanks for checking out the video. Make sure to read the comments for my support links, and until the next video, get out there and make something awesome.